The James Webb Space Telescope, JWST, the most powerful telescope in history, is revolutionizing our understanding of space. Recently, scientists using JWST made an amazing discovery: 6 megagalaxies that formed in the early universe when it was a hot and dense mixture. As JWST continues to explore, it will reveal even more distant and ancient galaxies, each with unique properties. But the most striking discovery is the detection of organic material, including the building blocks of life, in one of these ancient and primitive galaxies. This breakthrough will change our understanding of space and could have profound consequences for our future. Astronomers using JWST have succeeded in identifying the most distant organic molecules in the universe. This is the first time that complex molecules have been found in the distant universe. These molecules, found in a galaxy called SBT 0418-47, are more than 12 billion light-years away. Since the universe is about 13.7 billion years old, this galaxy is very old. A cosmic smoke ring-like structure indicates the presence of complex organic molecules such as smoke or smog. This discovery provides information about the chemical interactions that occurred in the earliest galaxies and how they relate to star formation on Earth. These molecules, known as polycyclic aromatic hydrocarbons, are found in smoke, soot, fog, engine exhaust, and forest fires. Organic molecules are based on carbon, which is considered one of the building blocks of life because it is an essential element in the amino acids that make up proteins. The light from this dusty galaxy began its journey through space when the universe was less than 1.5 billion years old, just 10% of its current 13.8 billion years. Using JWST's abilities to detect light invisible to the human eye and penetrate cosmic dust, new details of the galaxy were obtained. The Space Observatory benefits from gravitational lensing, a phenomenon that occurs when two galaxies are almost perfectly aligned from our perspective on Earth. This causes the background galaxy's light to change and increase as it passes close to the foreground galaxy, forming a ring called an Einstein ring. Gravitational lensing, originally predicted by Albert Einstein in his theory of relativity, increases magnification, allowing us to observe galactic components of the early universe that we otherwise cannot see. During a deep analysis of the JWST data, astronomers discovered the characteristics of organic molecules in an unexpected way. This surprising discovery will help astronomers answer fundamental questions about the origin of the universe. It's amazing that scientists can detect molecules billions of light-years away that are similar to the ones we know here on Earth, but are often associated with unwanted forms like smoke or smoke. Since launch, JWST has made headlines for its massive galaxy observations. Now it has made new discoveries that may change our understanding and require a major revision of cosmological theories. These groundbreaking discoveries could significantly impact our current knowledge and continue a series of discoveries that cast doubt on the Big Bang. JWST discovered the most distant galaxy cluster ever seen, 30 billion light-years away. This cluster is probably one of the largest in the universe today. Although the Hubble Space Telescope had previously observed the 7 galaxies that make up the cluster, scientists did not know exactly how far apart they were or whether they were connected as a group. Because it takes time for light to travel from these distant objects to the JWST telescope's location in solar orbit, we are looking at these galaxies as they were about 650 million years after the Big Bang. The current form in which we see the protocol cluster looks small. However, if we could detect it immediately without the limitations of the speed of light, it would most likely appear massive, capable of exerting a gravitational influence on thousands of galaxies. The researchers' simulations suggest that this protocol cluster may be one of the largest clusters in the universe today. JWST recently made a surprising discovery when it found a small galaxy that existed 13 billion light-years ago and was developing stars at an extraordinary rate for its small size. It is thought to be the smallest galaxy ever found at that distance, some 500 million years after the Big Bang. In a groundbreaking discovery, a team of researchers from the University of Minnesota used JWST to probe more than 13 billion years into the past and discovered an exceptionally small galaxy that evolved extremely quickly for its size to develop stars. This tiny galaxy exceeds the capabilities of all telescopes except the James Webb, and the first glimpse of this distant galaxy is truly impressive. Although the galaxy is about a millionth the size of the Milky Way, it forms the same number of stars every year. This is a fascinating phenomenon. If you want to know how JWST can detect such small details in a field wide enough to capture an entire cluster of galaxies at once, don't hesitate. The field of view of the legendary JWST is wide enough to image an entire cluster of galaxies at once. This is mainly due to gravitational lensing, which bends and magnifies light from the mass of a galaxy or cluster of galaxies. Gravitational lensing played a crucial role in making this small galaxy 20 times brighter than it actually is. This may be the first time that we have the opportunity to observe such a distant part of the universe, almost to the moment of the Big Bang. JWST, with its unique ability to observe galaxies, has made this task easier than ever. Until now, we have only had 2 space observatories that have been able to create deep field images that allow us to see the universe in unprecedented detail: Hubble and James Webb. Hubble operates in the visible light region, while Webb focuses on the infrared. Although both capture images of distant galaxies in dimly lit skies, the Webb images are sharper due to their infrared capability. By comparing the deep field captured by these telescopes, we can appreciate their significant differences. The Webb images have a distinctive appearance compared to the Hubble images, most clearly seen in the appearance of the stars with their characteristic sharp diffraction peaks. These peaks are unique features of Webb's images due to their specular shape. Webb's ability to observe objects in the infrared gives it a significant advantage over other space telescopes, including its predecessor Hubble. Webb is now revealing many objects that were hidden or missed in Hubble's deep field images. If things go this way, 2023 is likely to be full of discoveries that will change our understanding of space. JWST, a marvel of modern astronomy, continues to unravel the mysteries of the universe with each observation. Launched to study the cosmos in unprecedented detail, JWST has already made important discoveries that challenge and expand our understanding of the origin and evolution of the universe. One of JWST's most important features is its ability to detect faint infrared signals from objects billions of light-years away. This feature allows astronomers to look back in time and see galaxies as they were when the universe was young, a fraction of its current age. By studying these ancient galaxies, scientists hope to unravel the complex processes that led to the formation of stars, galaxies, and ultimately life itself. In recent observations, JWST targeted a region of the sky known as the Hubble Ultra Deep Field, HUDF, home to some of the faintest and most distant galaxies ever observed. Galaxies billions of light-years away offer a glimpse into the early universe and reveal the conditions that existed just after the Big Bang. By analyzing the light from these distant objects, astronomers can study the chemical composition of the early universe and trace the formation of heavy elements such as carbon, oxygen, and nitrogen. One of the most exciting aspects of JWST discoveries is the detection of organic molecules in distant galaxies. Organic molecules are the building blocks of life as we know it, and their discovery in the far reaches of the universe suggests that the ingredients of life may be spread throughout the cosmos.
JWST's ability to detect these molecules in such distant and ancient galaxies provides valuable information about how life may have originated on Earth and whether similar conditions exist elsewhere in the universe. In addition to studying individual galaxies, JWST is also equipped to study larger structures known as galaxy areas. These clusters contain hundreds or even thousands of gravitationally bound galaxies, making them the largest gravitationally bound structures in the universe. By studying galaxy areas, astronomers can learn more about the distribution of dark matter, the mysterious substance that makes up about 27% of the universe's energy mass. One of JWST's most ambitious projects is to study the formation and evolution of planetary systems around distant stars. Planetary systems, like our own solar system, are thought to form from disks of gas and dust surrounding young stars. By observing these disks with JWST's infrared instruments, astronomers hope to better understand the conditions for the formation of planets and the factors that determine their composition and habitability. Another area of focus for JWST is the study of exoplanets, i.e. planets orbiting stars outside our solar system. Since the discovery of the first exoplanet in 1995, astronomers have identified thousands of these distant worlds, from small rocky planets to massive gas giants. JWST's advanced instruments allow scientists to study the atmospheres of exoplanets in unprecedented detail, looking for signs of water vapor, carbon dioxide, and other molecules that could indicate the presence of life. In addition to its scientific discoveries, JWST is pushing the boundaries of technology and engineering. The telescope's primary mirror, 6.5 meters, 21 feet in diameter, is the largest mirror ever launched into space. The mirror had to be turned up to fit inside the payload of the Ariane 5 rocket flying into orbit,